All right, honors, probability and stats. This is chapter 9.3. And the reason I want to do 3 examples, you kind of know what's going on with hypothesis testing. The only thing that's going to be different, instead of mu equaling, it's going to be p. Okay? So as we read through these questions, I'm going to do 3. 1 less, 1 greater, and 1 in between. 1 to tell. We're going to highlight the important pieces. Are most student government leaders extroverts? According to Myers-Briggs estimate, about 82%, so 82% everybody is going to be our P. That's what we're going to be testing. Of college student government leaders are extroverts. Suppose that Myers-Briggs personality preference test was given to a random sample of 73 student government leaders attending a large national leadership conference, and 56 were found to be extroverts. So what they're doing is they're giving you the sample proportion in numbers. All right? And that's from a sample. Does this indicate that the population proportion of extroverts among college student government leaders is different in either way? That means greater or less. So that tells you right now that we have a 2-tell test. And we are going to use a level of significance of 0.1. So those are the pieces of information that you need. Let me go over in red. The 82% is our P. Between these two numbers here will give us our P hat. Oops, wrong. Where's my backwards on this guy? Jeez, sorry about that. On draw. That'll give us our P hat. Different will tell us it's not equal to for our hypothesis, our alternate hypothesis, and that is our level of significance. So here we go. I'm going to ask you for these pieces of information. Question A, I'm going to ask for the null hypothesis, and it's H naught. P is equal to the 82%, but since it's a proportion, we write it as a decimal. You see, you can't put 82% into your calculator, so let's do it now. Please make sure you do that. Question B is our alternate hypothesis, which is H sub 1. And that is P. Different means not equal to 0.82. Question C, which is the only thing different than what you did on your test for 9.1 and 9.2, is I'm going to ask you to find P hat. P hat is R divided by N. The number of successes were 56 out of the 73. On the quiz, and whenever we take any test on this particular stuff, I will ask you for P hat to go to 3 decimal places. So 3 decimal places for this problem would be 0.767. Null, alternate, P hat. The fourth thing we're going to find, everybody, is our z-score, our test statistic. For a population proportion, the formula looks like this. It is P hat, take away P, divided by a population standard deviation, which is known as P, times Q over N. So my P hat in this problem is the 767, which you found. And we're going to subtract the P, which is the 0.82. We're going to divide that by P, which is 82, times 0.18. Remember, Q is 1 minus P, divided by what N is, and N in this case is 73. Everybody should know that a z-score is 2 decimal places, so this comes out to negative 1.18. Null hypothesis, alternate hypothesis, P hat to 3 decimal places, test statistic Z. Question E, we're going to have to find our p-value. Our p-value is found by drawing a nice little picture of a standard normal curve, labeling about where negative 1.18 occurs. But remember, everybody, if it's 1.18 and it's a if it's negative 1.18 and it's a two-tail, we also need a positive 1.18. Your job is to find this area here and this area here. Now remember, they're the same. So if you look up negative 1.18, negative 1.18 looks like a 0.1190, 0.1190. That means this over here is also 0.1190. That makes sense, everybody? So, question F. We're going to find our p-value by adding 1190 and 1190, giving us 2380. So our p-value is 2380. We're going to compare that to our O1. I'm going to put an O1 right here, and I'm going to leave space for either a greater than or a less than. Everybody, what is 0.238 in comparison to O1? Greater than. Question G. I'm going to ask in basically layman's terms, what does that mean? And it looks like this. You will write, since the p-value is large, right? Because that greater than means large, comma, we fail to reject H naught. Now please understand, when you have the word large, you will have the words fail to reject. Fail to reject. And lastly, question H, we're going to write the conclusion according to the problem. So if you have the word large and you have the word fail to reject, what words am I going to start with? There is not enough evidence. Okay, so for this problem, there's not enough evidence that the population proportion of extroverts among college student government leaders is different from 82%. So, what words do you need to memorize? There is not enough evidence that the population proportion. Guys, remember on the ones we just did? It dealt with mu, and after those words you talked about the average, because that's what mu was. We're talking about P in these questions. So therefore, you need to memorize what I underlined in red. There is not enough evidence that the population proportion, and then whatever the problem words are is where you finish the problem, okay? But that red words are needed, okay? That's our first example. In our second example, USA Today reported about 47%, there's your P, of the general consumer population in the United States is loyal to the automobile manufacturer of their choice. Suppose Chevrolet, this is a study, this is a sample, of 1,006 Chevy owners and found that 490 said that they would buy another Chevrolet. Those are the two numbers, everybody. N and R, that will give you your P hat. We want to know, is the population portion of consumer lawyers to Chevrolet is more than, and we're going to use an O1 significant level again. So those are our pieces of data that we are going to use for this example. Let me write 47% so we don't forget it. Scroll up. And here we go. Question A, null hypothesis. P is equal to 0.47. Question B, alternate hypothesis. P is more than, so that means greater than 0.47. Question C, find P hat. I'm not going to write the formulas this time, so I did it on the first example. It is 490 divided by the 1006. Squiggle, squiggle, that gives me 0.487. 0.487. Remember, 3 decimal places for P hat. Question D is our test statistic. It is our P hat, 0.487. Take away the P, 0.47, over 0.47 times 0.53, square root of 1,000, over 1006. Take the square root of the whole thing. Plug this all into our calculator, and it spits out 1.08. Positive 1.08. It should be positive because we're doing a more than problem. Question E, we are going to draw our standard normal curve. We're going to put 1.08 here. We're going to know that we're supposed to find that percentage. But ladies and gentlemen, be very careful. When you look up 1.08, I'm doing it on my piece of paper now, I get 0.8599. I must do what, everybody, to get the red area? So 1 minus 0.8599 is 1401. This little piece is 0.1401. That, ladies and gentlemen, is your p-value. You don't have to double it because it's not a two-tail. So that means our p-value is 0.1401. We're comparing it to 0.01. So, ladies and gentlemen, it's another what? Another greater than. So if it's another greater than, we're going to use the same words we use. And it looks like this. Since the p-value is large, comma, we fail to reject H naught. So if you fail to reject, there is not enough evidence the population proportion of loyal customers to Chevrolet is more than 47%. Okay, so please understand, there is not enough evidence is because it's large and we fail to reject. Population proportion is there, and then we talk about the problem. This talks about the loyalty of customers to Chevrolet, and more than 47% is also needed. Okay, the last problem, number 13, we'll take a look at. Let's hit all of the important pieces. The following is based on information from The Wolf of the Southwest, The Making of Endangered Species by David Brown. Before 1918, the proportion of female wolves in the general population was about 50%, so that, everybody, is our P. However, after 1819, southwestern cattle ranchers began a widespread effort to destroy wolves. In a recent sample of 34 wolves, there were only 10 females. So that's our sample. That's our R and our P respectively, our R and our N respectively. Does this data indicate that the population proportion of female wolves is now less than, so now we have a left tail test, and we're going to use that 0.1 percentage again, okay? So here we go. We're going to start with our P hat, our H naught. H naught, this is question A, everybody, question A. P is equal to 0.5. Question B, H1, P is less than 0.5, right? Because it's less than. Question C, we're going to find P hat. Of the 34 wolves, 10 were females. 34 wolves, 10 were females. So that gives us, what? 0.294. 0.294. Remember, 3 decimal places. Question D is our test statistic Z. We're testing the 294 in comparison to 0.5. It's the square root of 0.5 times 0.5 all over 34. That gives me a negative 2.40. Question E, we're going to draw our picture, our curve. Negative 2.4 is way over here, which means we are looking just for this little percentage right there. It's nice because when you look up negative 2.4, it's going to give you the exact answer, 0082. 0082. So that's actually our p-value, everybody. Question F. Our p-value is 0.0082. And we're comparing that to 0.1, so this is less than. This is a less than problem. So we're going to chance to see what that means. Question G. Since the p-value is small, right, because it's less than, comma, we reject H naught. Okay, so when it's small, you reject it. And then the words look something like this. There is enough evidence. All right, there is enough evidence that the population proportion of female wolves is less than 50%. Whoops, not 5. Is now less than 50%. That's what they're trying to show. Okay? So, ladies and gentlemen, what I did in these 3 questions, that's the only thing you need to know about chapter 9.3. Less than, left tail test. Greater than, right tail test. Different or change, 2 tail test. And we have to answer every one of these questions. Going over them again, you have to know the null hypothesis, the alternate hypothesis, P hat, test statistic Z, how to draw a standard normal curve and label it, how to set our p-value in comparison to our level of significance, the terminology, explanation, and then the explanation of the problem itself. And ladies and gentlemen, that is chapter 9.3.